In this example, we're going to focus on a concept called stack unwinding. The exception handling mechanism is always based on the method call stack. Wherever the exception is thrown is called the throw point, and that's generally going to be the top method on the function call stack or the method call stack at a given time. And if we choose at that level of the stack not to process the exception, the method call stack will be unwound. That is, we will keep returning to the prior methods in the stack until we find a point at which we can catch and handle the exception, or until we unwind the stack completely, which, depending on the type of your program, could actually cause the program to terminate, or at least cause one of the threads within your program to terminate. Java, as you may or may not know, is actually a multi-threaded programming language, which means that you can actually have parallel paths of execution that are physically executing at the same time, and therefore each thread maintains its own separate method call stack. So what we want to do in this example is demonstrate what happens if we don't catch an exception where it is thrown, and show you that in fact the stack will unwind and that we will be given an opportunity to catch the exception in an earlier method call within the method call stack. So in this example, once again, we have a static main method which is going to be calling a static throw exception method. In main, you can see that we have a try block that is wrapped around the throw exception method call. We're going to call that method. It's going to throw an exception back to us, which we will catch here, and after we catch it, we will print that the exception was handled in main. Now, in our throw exception method, you can see that once again we have the throws clause, and that is because class exception is a checked exception, and I have to meet Java's catch or declare requirement for checked exceptions, which means I'm either going to catch any checked exceptions in the body of this method and deal with them, or I'm simply going to designate to the caller that I'm throwing those exceptions back to the caller. In this case, I'm choosing to throw them back to the caller once again. Now, in our throw exception method, we have a try block, and it's a mechanical example once again in which we first print out where we are in the code, which is in method throw exception, and that gives us the first line of our output window here. Then we show you that we're throwing a new exception object. Now, again, exception is a checked exception type. We are in a try block, so the try block is going to terminate, and we're going to jump to the first catch block after our try block. Now, in this case, the catch block is catching type runtime exception, which is not a superclass of type exception. So this is not a matching catch handler. So this code in lines 26 through 30 will be ignored. Because I did execute the try block, the finally block will execute. So I print out finally is always executed next, and you can see that as the second line of output here. And now, because we did not catch the exception from line 24, this method is going to terminate even if I had other code to execute between line 34 and line 35. So the method is going to terminate and return to the caller, which is the unwinding of the method call stack. So now throw exceptions no longer on the stack. Instead, we're back at line 10. The system recognizes that we're in a try block and that we have an exception to catch. It jumps out of the try block and goes to the first catch handler looking for a match. The catch handler is indeed catching the type of exception that I had thrown, so we catch it here and we print out that the exception was handled in main. So you can see that is our last piece of the output. And then we've successfully caught that exception, so we simply move on to the next thing after the try-catch sequence, which happens to be the end of main, so our program terminates. So if in a given level of the method call stack an exception occurs and we don't catch that exception there, the stack will be unwound until we find a corresponding catch block that catches the appropriate type of exception. If by any chance we don't find such a catch block, then main will terminate without catching the exception in our example, and that would cause an error message at the command line and premature termination without a useful error message that would be understandable by the user of your application.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.